Hey kids, this is Mr. Martin. Today we're going to talk about Chapter 1 of the Essentials of Geography. When we look at the science of geography, geo means earth and graphene means to write. So geography means to write about the earth. Geography is a science that studies the relationships among geographic areas, natural systems, society, cultural activities, and the interdependence of all of the above through space. So when we talk about the idea of spatial, geography is a spatial science. The spatial part refers to the nature and character of physical space and the distribution of things within it. So when scientists, geographic scientists, look at the world, they're looking at the relationships of all of the components of things that they are studying. It can be everything from grains of sand in a desert to the population distribution of people across a continent. But what geographers ask is the question of where. Where and why? Why are those things there? So, geographic science has 5 themes. The 5 themes have been around forever. It's location, place, region, movement, and human-earth relationships. If we look at this, it talks about the different things in the 5 themes of geography. When we talk about location, that's a specific spot on the planet. So we can use GPS coordinates or latitude and longitude coordinates to find the exact spot of your house or of a school. But then geographers also talk about the place of things, and place is different than location. A place is the characteristics of a particular location. So, for example, in Dallas, Texas, we have a very unique place in that we have a different physical environment than most places. It's very different. It's slightly hilly. It's got streams. It's got lakes. It has trees and some prairies. And that place is made up not only of the physical aspects of the environment, but the people who live here. It's a very multicultural place. We have a unique characteristic of what we think of Texas as being like, plus a great tradition of immigrants from all across the country over a millennia of time that has made a very nice patchwork of a multicultural place known as Dallas. The place is the unique characteristics, which is much more interesting and vibrant than talking specifically about a location. You go on from place and you can talk about a region. Dallas is part of the South Central United States, so you can classify things that might make sense for talking about Oklahoma and Texas together. Or if we talk about the Southeast United States or the Western United States, there are different regions which are places that have common characteristics. You can study beyond a region and talk about not only the people and places, but how things move. Many times, geographers are not interested about just the place and location that things are at, but how they move and how they move over time. And most importantly, in my opinion, or at least the most rich part of the geographic science, is human and earth relationships. You see that in a lot of texts as human environment interaction, but we'll study a lot about how we as people, as humans, do impact the earth. And we make a huge carbon footprint, every single one of us, and we make decisions every day on whether or not we add to that or help the environment. And those are some of those discussions that are most unique in. We'll also look at the human-earth relationships, which in some texts is human-environment interaction. And this is one of the richest area of the study of geography because we look at how we as people actually impact the physical environment around us. We'll talk about pollution, we'll talk about environmental law and government, and we will talk about practices and policies which help with our environment or harm it. So that's an area that is of most interest to me in the study of geography. So the scope of geography, because it is a study of where, geographers ask where things are and how they got there and how they moved, it impacts almost all of the sciences one way or another. The field of geography is very vast because you can study and use geographic concepts across almost any of the disciplines in academics. One other tool that geographers use is a scientific method. And with the scientific method, geographers will go through this process to try to make sense of the real world. So, for example, they make observations of the real world. And from those observations, they're going to form a hypothesis. which is basically a logical explanation of what they're seeing in the real world. But they have to do an experiment to measure and to check and to make sure that their hypothesis stands up to a test. If the results of their test support their hypothesis, then they ask peers or other geographers and scientists to do a peer review. And their peers will communicate their findings for evaluation for other scientists. And if all the peers say, yeah, your research is good, you will have developed a scientific theory. If you experiment and measure on your hypothesis and you don't find out that what you think you're seeing is actually true, you're going to reject your methods and go back up to observe the real world. So this is an active method or an active way of which geographic researchers make sense of the real world. So people have definitely impacted our planet. If you look at the population growth, in 1960 there were 3 billion people. In 1970 there was roughly 3.7 billion. That was around when I was born. So since I was born, we've more than doubled the population to over 7 billion in 2020, and we keep climbing. So you have to ask yourself, how much can this planet handle? At what point will we have too many people to sustain a food resource, to sustain clean water, and to sustain a clean enough environment to inhabit more people? So at some point there has to be, if the population continues to grow and continues to grow and continues to grow, one thing that is fixed is the space of the earth. We can't increase the size of the earth. That's a fixed thing. So one thing that we talked a lot about in geography is this idea of overpopulation and population growth. And there's a lot of countries that have reached very difficult situations. Like in China, they will only allow so many children per household because of their overpopulation issues. So the main question is, how are we impacting the environment, especially as our population as humans increase? So there's two kinds of systems. There's an open system and a closed system. An open system has inputs of energy or matter and outputs of energy or matter. So it's things that things come in and things go out. A closed system is shut off from the surrounding environment, so it's self-contained. So closed systems are rare in nature. Usually in nature, most things are open because most things take inputs. Like we as people take oxygen in, we take food in, and then we have outputs as well. So the Earth is an open system in terms of energy. We get our energy from the sun. But it's also a closed system in terms of physical matter and resources. Okay, in this class, we're going to talk about Earth's four spheres. We have four spheres. Four spheres. Okay, in this class, we're going to talk about Earth's four spheres. We have the atmosphere, which is the system of which all of the air flows. We have the lithosphere, which is the system of which all matter flows. We have the biosphere, which is the living part of the planet. And then we have the hydrosphere, which is everything, which is a system that involves everything that is water. So all of these spheres interact with each other. For example, water in the ocean will evaporate into the atmosphere, will rain down and create fresh water for the biosphere, will weather the mountains. So all of these are interacted, but they are their own unique systems. Okay, let's talk a little bit about the Earth and the actual physical size of the Earth. When we look at the Earth's North Pole is actually tilted a little bit. So as we revolve around the sun, we're actually at a tilt the whole way around in our orbit. If you look around the circumference of the center of the Earth, north and south center, you're going to see that it's 24,902 miles around the axis of the Earth. If you do the north axis, it's 28,860 miles. So we're actually slightly squished. So when we look at the Earth, it's slightly elliptical. It also is slightly tilted. So let's talk about latitude. Latitude is an angular distance north or south of the equator, measured from the center of the Earth. So here are the lines of latitude. Latitude measures how far north or south you are along imaginary lines of the Earth. Now, when I think of latitude, a lot of people get latitude and longitude confused. Lat is fat. Lat is fat. Latitude goes around the belly, around the Earth. So latitude are those lines that run east-west and divide the Earth north-south. Okay, when we look at latitudinal geographic zones, we can see that these lines of latitude can also talk about the predominant weather and zones that are in these areas. So, for example, we have equatorial and tropical zone. So, why would you want to go down to Cancun or parts of the Caribbean or Hawaii? Because you're in the tropical zone. You're close to the equator, and man, you got great beaches. Subtropical zone is where Texas is, and it's a little bit further north. And most of the weather in here is characterized by weather patterns of cold fronts, and we'll talk about that, cold and warm fronts that move. Then you have the subarctic zone, which is a much colder zone. You think more typically of Canada. And then you have the Arctic zone, which is primarily frozen on both sides. So our latitude also cuts the Earth into different zones that we can use to describe different physical phenomena of the environment. All right, longitude is an angular distance east or west of a point on the Earth. So we're talking about how far east or how far west. So when you think of longitude, think of long-legged. It goes up and down on the globe. It is very long-legged. And everyone's longitude starts at 0, which actually goes through Greenwich, England, which is also called the prime meridian. The reason they chose Greenwich, England is because, hey, England was the center of the universe whenever they figured out these lines of longitude. And so they were going to start at 0 in England because they were the biggest empire on earth at that time. Okay, let's talk about time zones. When we look at time zones, the purpose of time zones is the Earth is round and the Earth rotates. And so the sun moves across the face of the Earth as the Earth rotates. Well, every country wants to have their day during daylight. So their day is set around where they are on the globe. So if you look at the prime meridian, where we'll start in England, it's 7 o'clock p.m. there. Well, it's 7 o'clock in the evening in England. It's 6 o'clock in the next time zone, 5 o'clock in the next time zone, 4 o'clock in the next time zone. So as you move west over the map, you can see each time zone is actually an hour earlier. This is why when I was in France over here and it was 7 o'clock p.m. and I wanted to call Dallas, I was calling actually my friends in Dallas that were having lunch. I'm eating dinner, they're having lunch. Okay, let's talk about the international dateline. This is kind of a hard concept to understand, but the dateline is roughly at the longitudinal meridian of 180, but it zigs and zags around. Like here, it'll take all of Russia is over here, and then all of Alaska is on this side. And then it zigs and zags for different political reasons, for no real main reason at all, other than for example, to divide countries like up here, Alaska and Russia. And the Earth rotates this way. It's always moving from the west to the east, which is why if the sun is out here, think about it. If the sun is here, the Earth is rotating this way, the sun will hit New York before it hits Los Angeles, which is why New York is ahead of Los Angeles, or further in the future as far as the time zone is concerned. Like in New York, when it's 4 o'clock, it's 1 o'clock in Los Angeles. Well, as this moves, the day will start here. And so 12 o'clock a.m., it will move this way, and then you'll have 1 o'clock, and then you'll have 2 o'clock, and you'll have 3 o'clock, and you'll have 4 o'clock, and there's 24 time zones around the Earth. And as that day comes here, the day ends at the international dateline. So November 1st will start here, will rotate around for 24 hours, and will end here. Well, so if November 1st starts here and ends here, what's on this side of the dateline? November 2nd. Because every day starts at the international and ends at the international dateline. So if you're sailing a boat and you go across the international dateline, you will actually have to add a day. It will be November 2nd here, November 1st here. Or vice versa, if it's November 2nd on this side and you sail across over here, you have to subtract a day because every day begins and ends at the international dateline. Okay, let's talk a little bit about maps and cartography. You see maps a lot of the times in lots of places, but a map is a view of an area as seen from above, and greatly reduced in size. So example, if you had a map of Texas, you would see the shape and the roads and those type of things. So map scale is a ratio of the size of a map to the size of that area on the ground. When we look at this, these are small and large scale maps. So like this is the Miami region, and this is just downtown Miami. So if you were walking in downtown, you might want to look at this map. If you're trying to find your way from the airport to downtown, you might want to look at this map. But when you look at the scale, every inch is 6 miles here, where every inch is 2,000 feet. So the scale changes depending on the scale of the map. Okay, if you think about it, a map is flat, but the Earth is a sphere. So when we take a spherical object and flatten it out, it'd be like taking a baseball and ripping the skin off and making it flat. You'd have jags at the top and the bottom because you have more material around the middle than at the top. So because of that, when you take a map and you flatten it, you kind of all of the projection has distortion. So when you look at this kind of a map that you see a lot of times, this is North America and Alaska, and here it is flattened out. You actually have a lot more distance around this part than around this part because you flattened it out as best you can. So in order to actually make good projections of maps, you can't actually take a cone. I mean, you can take a cone and you can flatten it out this way, and you can see Greenland will be smaller in this projection than this projection. Or a lot of times we have an oval projection, which also helps with that map distortion. But your flat maps of the world are the most distorted. Like here, Antarctica looks huge, and in reality, Antarctica is not nearly that big. In your oval projection, you can see Antarctica looks much more reasonable in its shape and size. Okay, let's talk about the modern tools and techniques for geosciences. The Global Positioning System uses satellites to triangulate your position. So if you're out in the wilderness, or if you are driving your car and you can see the map or looking at your cell phone, it's using GPS to find your exact location. Remote sensing is when you look at locations without using your own eyes. So sending up drones, sending up aircraft and looking at locations through radar, looking underneath the water through sonar, that's remote sensing, which is looking at our physical environment through machinery. And then geospatial data analysis, or geographic information systems, is the collection of all the data into a computerized system to analyze different spatial data. So when we look at GPS, it triangulates your location. You have one satellite, two satellite, three satellite in a location, and the satellites are in fixed spots in orbit. So it can triangulate your location exactly on the planet based on their locations in space. Remote sensing refers to obtaining information about something without having direct contact. So often visible imagery, but can be other data like looking at temperatures, levels of chemicals, infrared or UV wavelengths, but it's basically looking at things using technology. Okay, let's talk a little bit about Geographic Information Systems, or GIS. So let's take a look at Geographic Information Systems. You'll hear a lot about Geographic Information Systems, or GIS, which are computer programs that process spatial data about things. So they look at where things are and what they are. So they can have multiple data layers, like one layer will be its physical features, one could be its cultural features, and the layers can be added to create composite overlay. So a geographic information system will look at data something along this line. So you might have a layer of soils, a layer of land cover, a layer of wetlands, a layer of floodplains, a layer of zones, a layer of parcels, a layer of digital base map, and you can look at the data from each of these different layers through the geographic information system. If you've ever worked with Photoshop or photo editing and you have the different layers of a photo, GIS separates out each of the layers of something that a scientist would be looking at. So think of it in terms of a large, this is one area of the Earth broken into multiple contents of data and information. So that's it for Chapter 1. We also have a Chapter 1 outline that you can look at here. I also have the PowerPoint uploaded on our Blackboard site, so you can go through at your leisure as well. Good luck on the Chapter 1 test.